So in this is the lecture 2 of geodetic surveying. In geodetic lecture 1 of geodetic surveying, we have discussed about introduction of geodetic surveying, introduction of triangulation system, classification of triangulation system. Okay, in geodetic surveying, what we will do, we'll divide the large area in number of triangles and will determine those points, those points of triangles very accurately, very precisely, and for this will apply the geodetic surveying. So the geodetic surveying will give us accurate readings or accurate points of the area. Okay, and in triangulation system, what we'll do, we'll divide that area in number of triangles and we'll conduct the survey. The apex point of those triangles are called as triangulation station, and the whole area which is divided in number of triangles is called as triangulation system or triangulation figures. Don't get confused. And the classification of those triangulation systems are first order or primary triangulation, second order or secondary triangulation, third order or tertiary triangulation system. These are the three classification of triangulation system. And next is about triangulation figures or triangulation system. The triangulation figure is a group or system of triangles such that any figures has one side and only one common to each of the preceding or following figures. So triangulation figure or triangulation is a system is nothing but a group of triangles such that any figure has one side which is common to all or which is a baseline. Okay, and only one common to each of the preceding and following figures, which we will refer as the baseline. See, common figures which we adopt to conduct the work are single chain of triangles, double chain of triangles, central point figure, and next is quadrilaterals. Okay, single chain of quadrilateral, this figure is used where the narrow strip of terrain is to be covered. So this method will be used in where the narrow strip of terrain is to be covered. This method is rapid and economical, so it is not accurate for the primary work, since the number of conditions to be fulfilled in the figure adjustment is relatively small. So this is nothing but at site what happens there, some error may occur. To overcome that errors, we have to adjust some lines or some stations, so that is relatively small in this case. Okay, so and also it is not possible to carry out the solution of triangle through the figure by two independent routes. That is nothing but for the faster work or for easy work, what we'll do, we'll go for two independent route, and that is not possible in this method as the terrain is narrow terrain. As this strip is the narrow strip of the terrain is used here, so that's why the forming of two independent route is not possible in this case. So you can see the figure here. This is one narrow strip terrain and this is the triangle formed for the conduction of work. So what is single chain triangles? This will be used where the narrow strip of terrain is to be covered, and this one is the economical and rapid method. So this one is the not accurate for primary work. Okay, so this one is about single chain of triangles. Next is double chain of triangles. This is also same as single chain, but here larger area can be covered. This is used to cover the greater area. You can see here, this one in this area is divided in two part, here one part, here one part, and this is the chain. Okay, this is double chain. So here you can go for two independent routes. Next is centered figures. Centered figures are used to cover the area and give a very satisfactory results in flat country. This method is used where the flat area is available. The centered figures may be quadrilateral, pentagons or hexagons with the centered stations. So what they'll do, so you can see here figure, they'll fix one center station and they'll take the reading of that whole area, or they'll divide that whole area after fixing the center station. See, this one is the quadrilateral, here the center station, this is the pentagon, this is the central station, this is the hexagon, and this is the central station, and this is the double centered figure. So this is the double centered figure, you can observe here. So what they'll do, they'll fix one center station and they'll take the readings. However, the progress of the work is slow due to more setting of instrument. So whatever, as the number of stations increased, the number then setting up of instrument is also increased. Again you have to shift the instrument, take the readings, again shift the instrument, take the readings. So this will be slow here, the work will get slow due to more setting of instrument. Next is quadrilaterals. The quadrilaterals with 4 corner stations and the observed diagonals form a best figure. You can see here, this is the quadrilateral with 4 corners, these both are the quadrilateral with the 4 corners and 2 diagonals. Here also 4 corners and 2 diagonals. They are the best suited for hilly country, and this system is more accurate. For hilly area you can go for quadrilateral system. Okay, and this gives the most accurate readings. Next is the criteria for selection of triangulation figures or triangulation system. So how will you select the triangulation figure or system? The triangulation figure should be such that computation can be done through independent routes, done through 2 independent routes. So you have to select the figure such that the computation can be done through 2 independent routes, so that the work will be faster and it will be easier. Okay, so for that it should be it should be done with the 2 independent routes. Next is the triangulation figure should be such that at least one or preferably both the routes are well conditioned, nothing but well determined. At least one route or preferably both the routes should be well determined, so that work should be done easily, should not be more difficult. And next, all the lines in the figure should be comparable length. Very long lines should be avoided, there should not be very long line, then taking the readings will be difficult. And next, the figure should be such that at least figure should be such that least work may secure maximum progress. So at least figure should be formed in such a way that at least least work may proceed towards the maximum progress. And next is complex figures should not involve more. Complex figures should be avoided. Next is baseline measurement. How will you measure the baseline? See, the measurement of baseline forms the most important part of the triangulation operation, because see, this one play the most important part of the triangulation operation, because you are referring the baseline only to forming the figures, to calculate the angles or forming the angles. You are going to refer baseline only, so that's why it plays an important role or important part. Okay, so in that, the baseline is laid down with great accuracy of measurement and alignment, as it forms the basis for the computation of triangulation system. As I told, basis for the computation for a triangulation system, so it should be laid down with the greater accuracy and alignment. The length of the baseline depends upon the grades of triangulation. The length of that baseline depend upon the grades of triangulation, means which triangulation system you are going to adopt. So depend on that, the length is preferred. Next, apart from the baseline, several other check bases are also measured at some suitable intervals. So in lecture 1 I have told in the errors, in removal of errors, the errors may occur in more errors occur in the length and azimuth. So to overcome that, the check bases are also measured at the some suitable intervals, not only baseline, some sub baselines also we can refer. Next one is orders of triangulation survey or routine of triangulation survey. So to conduct the work there should be some routine. The routine of triangulation survey generally consists of following operations. Reconnaissance survey, reconnaissance is nothing but exploring that area, that is how much is the area, what is the topography, what is the nature of that ground. Okay, so that is what reconnaissance survey. And next, erection of signals and towers, that one. And next is the measurement of baseline. After that you will mark the baseline and measurement of that. And next, measurement of horizontal angles and astronomical observations at Laplace station, because it is not sufficient as you are covering the whole country or the that much larger area. Only the measurement of lines or measurement of horizontal angles are not satisfied. So you have to go for astronomical observations also to cover up the all small points in that area also. So and next you will come for computation. Last method will be computation. After getting all the readings you have to go for computations. This is how the routine of triangulation survey is conducted. Next is selection of triangulation station. Now we have gone through selection of triangulation system, selection of baseline, how you mark the baseline. Now we'll go through the selection of triangulation station. Remember, system is different, session is different. System is the triangulation system is the whole area how you are going to divide, and station is the triangulation system. Station is nothing but the apex point of triangles. Okay, the whole area you have divided in a number of triangles. That is what triangulation system. And those triangles having that one highest point, that is what the apex point, that is what the triangulation station. So how will you select this triangulation station? Because at triangulation station only you are going to set up the instrument and take the readings. So you have to select that in such a way that it should be it should be easily visible from all the interconnected stations, all the lines. So for that you need to go for selection criteria. So first one is, see, the triangulation station should be intervisible. For this purpose the triangulation station must be placed upon the most elevated area. So all the triangulation stations should be intervisible, because the referring points and the proceeding points, following points all should be visible. Correct. If you are marking here one station, okay, so you are going to take the following station reading of following station, and also reading of proceeding station. So that's why these stations should be intervisible. So for this purpose this station should be placed on the most elevated or heighted area. Next is they should form well-shaped triangles as far as possible. So they should form well-shaped triangles so that the work go easily. Okay, and there should not be more difficulty. So the base angles are of about 56 degree or equilateral. The base angles which are going to use for reference, those should be 56 degree or equilateral. And in general no angle should be smaller than 30 degree and greater than 120 degree. It will be difficult. So that's why what they have given the guidance that in general no angle should be smaller than 30 degree and greater than 120 degree. The station should be easily accessible. That is nothing but it should be easily should be such that the food and water should be easily available. Okay, and next is the station should be so located that the length of the side neither too small or nor too long. Because what happens if the site is too small, then errors due to centering and bisection may occur. When the area is too small, then the centering and bisection will be difficult, or the error may occur in that. And also while the area is too large, what happens? The line of sight will make the signal too indistinct for the accurate bisection. Okay, if the length is too large, or too long, what happens, the line of sight may difficult. So it will not give the accurate bisection. Okay, and they should be in a commanding situation so that to serve as the control of subsidy triangulation. So when you are going to conduct the work on subsidy triangulation, sub triangle works, so the main triangle should command the situation that it should be control over that. Okay, because when you are referring the main stations, main station, it should be sorry, it should be good give reference. There should not be more difficulty while forming the sub triangles or sub areas. Okay, so that is what next one. Next is, in heavily wooden country, the station so located that the cost of the clearing and cutting of the building towers is minimum. So that is, obstruction should be minimum, clearing and cutting of the wood should be minimum. And see, the station should be situated there so that line of sight should not pass over the towns, factories or towers, signals. Okay, so the obstruction should be minimized or avoided, as possible as avoided. So this is about the selection of triangulation station. Okay, this is about selection of triangulation station. That is, it should be intervisible, there should be less obstruction, they should be easily available of food and materials, and also water. And next, the large and too small and too large lines are avoided, so errors, to overcome the errors. Okay, so next is marking of these triangular station. Now you learned about how to select the stations. Next is how you will mark the stations, because when you are going to conduct a survey of whole country, so for the reference you should know which point is which one, which station is referring which station is following by which station, the proceeding station, which is the proceeding station, which is the following station, you have to know that. Okay, or in some cases, in the whole, you can't measure or you can't take the reading of whole country at only one day. So there may be a break in a work, or in also for some future extension also you need the references. So the marking is important here. The marking of station is also important in this point. See, the triangulation station should be permanently marked with the copper or bronze tablets. As I told, if there you may conduct some future extension work, okay, or that whole country, surveying of whole country can't be completed at smaller time, okay, lesser time. So it takes time to measure the area. For that, the marking of that should be with the copper and bronze tablet. Okay, should not be washed. The name of the station and the year in which it is set should be stamped on the tablet. The name and the year should be written on that tablet, because what happens, consider here this is the session A and here is the session B. Okay, and you are referring this station A to form the station B, correct? So that's, you need that information while proceeding C, correct? So that's why, or for that's why you need the following point and the area in which it is marked, because after some years or after some long time the situation may change around that area. So you need the references from where that point is taken. Okay, for that all you need the name and the references. The following are the essential of good construction of station marks. The mark should be distinctive and indestructible. That is, the mark should be visible, easily visible, and it should not be get washed. Should be visible for longer time. See, two marks should be provided, one visible on the surface and other buried vertically below. What happens? See, here you have to mark the two marks. You have to provide the two marks, one on the surface and one the vertically below, because after some long time that mark may go. that mark may washed out. So you need, after that what you'll do, so for that when you mark another point vertically below, so that you can go through that point. So that's why they have given the instruction to mark 2 marking points. Next is the mark may set on the formwork on a concrete monument. That is on concrete mark may set on the concrete monument. And next is 2 or 3 reference marks similar in material and shape to the station mark should be installed. So here 2 or 3 reference mark similar in material and shape to the station mark should be installed. So as I told, when you are taking the reference from this A station to mark this B station, you are taking the reference of this A station, and that should be written here 2 or 3 reference marks. Okay, the distance and bearings of these reference marks from the station mark and for each other should be recorded on them. So see, consider here, if here is one station mark and here are another 2-3, so when you are going to take reference of these 2-3 points, so you have to mark in that from which point you are taking, from which all station you are taking the references, and which all stations are interconnected. You have to written on that, you have to mark on that station. To at each station where at all signal tower is needed, an azimuth mark should be established at some distance away from the station mark. Azimuth mark is nothing but, as I told, it is nothing but an arc of an horizon in a vertical scale, vertical axis. It is an imaginary arc of an horizon which at some signals and tower you need to mark in this also, because there you can't just directly see the previous point. Okay, if in some of the cases, what happens in some of the cases, you just mark the signals and towers as the session points. So in those cases you can mark the azimuth mark also. So this is about marking the station. How will you mark the station? So it should be visible. It should be visible for longer time. You should mark the 2-3 marks on that. You have to write the references points also, proceeding points also, and you have to write that with the copper or bronze tablets. Okay, this is about marking. Next is reduction to center. Just now I have told, at some cases the towers and signals are itself considered as the stations. So what happens when you consider the signals and towers as the triangulation stations? You can't set up the instrument on those tower or signal and take the readings. It will be difficult. So for that, what you'll do, you'll just set up an imaginary station or false station, or you can call it as satellite station nearby that, on the same level, same ground level, and you'll take the readings and you will reduce those readings. Later on you will reduce or convert those readings to the original station. That is what called as reduction to center. See here, in order to secure well conditioned triangle or better visibility object such as flagpoles, towers, etc. are sometimes selected as triangulation stations, as I told. When the observations are taken from such stations, it is impossible to set up the instrument over it. So for that, what they'll do, a subsidiary station known as satellite station or a eccentric station or a false station is selected near to the main station as possible. So the observations are taken to the other triangulation station with the same precision as would have been used in the measurement of angles at the true stations. As I told, we'll set up a near to that true station, we'll set up a false station and we'll take the observation, and these angles later on corrected and reduced to what they would have been if the true station was occupied. Okay, these angles later on corrected and reduced to true station. What if the instrument was set up in that tower only and taken the readings. Okay, so we'll convert to that station, will convert or will correct and reduce to readings to that station. The operation of applying the operation of applying the corrections due to eccentricity of the station is generally known as reduction of center. As I told, the operation of applying correction due to eccentricity, that is correction due to change of that instrument of the station, is generally known as reduction of center. Applying of correction due to eccentricity, due to change of instrument or change of station, is known as reduction of center. The distance between true station and satellite station is determined either by trigonometrical leveling and triangulation method. Satellite station should be avoided as far as possible in primary triangulation system, because in primary triangulation system it will create the more errors. That's why as possible as we have to avoid this method. This is about reduction to center. Reduction to center is nothing but in some cases we select tower signals or towers as the satellite station, as the triangulation station, so we can't set up the instrument on that tower. So what we'll do, we'll nearby that tower we'll set up a false station and take the readings angles, and then we'll correct those readings, we'll reduce those readings to the true station. That is called as reduction to center. Okay, so this is about geodetic surveying. So in second lecture what we have discussed, that is system of sorry, in this second lectures what we have discussed, that is triangulation systems or triangulation figures. There are three triangulation systems or triangulation systems, four: single chain triangles, double chain of triangles, central point of triangle, quadrilateral. Okay, and next after that, selection of site for criteria for selection of triangulation figures or triangulation system, and next routine of triangulation survey, that is reconnaissance, erection of signals and towers, measurement of baseline, measurement of horizontal angles, next astronomical observations and computations, and after that selection of triangulation station. After selecting the station, next is marking of triangulation station, and next is reduction to center. This is about geodetic surveying. Okay, thank you.